Hello everyone. In this video, I'm going to present DMODE, Differential Monocular Object Distance Estimation without class-specific information. Depth estimation has different approaches. There are a stereo camera, which uses two cameras and has suffered from desynchronization. There are 3D construction, which has problem with occlusion, non-texture regions, and motion objects. And then we have LiDAR, which are very expensive and has high failure rate. We have monocular visions that has three different approaches. Depth estimation, which use depth supervision and optical flow. Then we have 3D object detection, which uses 3D training and excessive info. And then we have object distance estimation, which learn object classes. And then we have DMODE, which doesn't use that. In the theoretical analysis in the paper, we showed that in a simple case of 1D object, how we can only use the information about the object sizes in order to get their distance. More information on the paper. What is DMODE? DMODE uses only a monocular camera. It is independent from object classes, camera intrinsic parameter, and it only requires camera extrinsic parameters, IMU data, and then training classes. So it is adaptable to different object tracking network, and we can use transfer learning to enhance multi-class estimation. Based on this figure, we can see the detailed architecture of the framework. We utilize a sequential network that stack the object tracking network and then try to find a relation for using different object tracking network. We deployed TrackRCNN and EagerMOT, and then there is a 2D network which we utilize ResNet 18, and then finally as a 1D network we use MLP. For the comparison, we see that our approach, even though that it was applied only on classes of car, provide very good result compared to other approaches. For the evaluation study, we apply it to training on ground truths for robustness. We apply it on the training on TrackRCNN to show the adaptability. And finally, to show the model agnosticity, we actually provide the test on ground truths with only training with the car class. First error for different distances, then we show the distance changes, and finally for the different acceleration. For the limitation of this approach, we can mention that both object detection uses only car and pedestrian, so we cannot actually show the priority of the proposed method. Then there is a time delay, and finally constant velocity object, which we use only 3 keyframes. So what we can do for the first option is that to use an end-to-end approach. For the time delay, we can use asynchronous, and finally we can provide a new framework that can work for better.